So tonight's topic is really interesting. My husband is a triathlete, and he spends hours in the garage doing the bike, riding his bicycle and running on the treadmill. And I was hoping I could convert some of those make a battery out of it or something. So I'm hoping in the future that would happen and light my entire house with the energy that he creates for us. So it's my honor and privilege as a chair to introduce our moderator tonight, Rex Northern. He is a serial entrepreneur, and he's been a founder and CEO of many technology companies, not only here in the US, but also in Europe. And here in the Valley, he's very well known as an executive director of Cleantech Open. He's the one who made it grow. It was a nonprofit organization, started here in Bay Area. Now it's a big national organization, and soon he's going to make it into international organization, I believe. And while he's not working, he is enjoying his time with his 2-year-old and 4-year-old boys. And soon, in June, he'll have a third accident child. So he'll be busy with the third one, and he's banned. His wife gave an okay to be here tonight, but he's banned to be traveling to DC. Anyways, without further ado, I would like you all to join me to welcome Rex.
Yes, I have a single slide. Let me just find a way of bringing that up before we get started. So thank you very much, Aiko, and thank you all the VLAB team for inviting us here this evening. It is a terrific topic. So as Aiko mentioned, I am the executive director of the Cleantech Open. We haven't had many entries in the energy harvesting space thus far, but one of those companies, Phoenix International, Brian Waszowski, where are you? Is here this evening, actually still downstairs enjoying the wine. But one of those companies is here. I am, as I mentioned, I am a neophyte in this area, but I'm going to give you, if I can find the deck. It's not it, and that's not it. It's none of those decks. Okay, well, never mind. Is there an easy way of fixing this? Hang on, let's go here.
Go to the desktop.
Let me just, there it is. So here is my single slide, which actually makes this look like a Cleantech Open event, which is not bad. There's a starting point for those of you who know the Cleantech. So here's the slide which explains that tonight is a VLAB panel about kinetic energy harvesting. I'm going to give you a neophyte's overview of what this space looks like. There are really 4 different technologies in energy harvesting. Vibration, which relies on the piezoelectric and electromagnetic effects. The thermal energy harvesting, which of course relies on the first thermoelectric effect. Small-scale solar, which relies on photovoltaic cells, and RF, which relies on electromagnetic fields, which would be harvested from something like a TV signal or a wireless network. So as with so many of today's exciting cutting-edge technologies, much of what you see today started life with basic science that was discovered many, many years ago. In fact, the piezoelectric effect was discovered by the Curie brothers in the early 1880s, and the first thermoelectric effect was discovered even earlier by Thomas Johann Seebeck in 1821. So what's the big deal? What's the big deal about something that's been around for such a long time? What's given the impetus in this space for us to be talking about cutting-edge technologies in 2011 and have a panel on this in a burgeoning space? Well, I think the answers are in the handouts you have this evening. There are kind of 3 big things we're talking about. The first of them, of course, is that we now have some very low power, Jeremy Walker, very low power, low cost microprocessors. There's this thing called Moore's Law, which has brought the cost and the size and the power required by microprocessors, incidentally, down. There are some particularly low power chips available today, which means that you can now harvest small amounts of energy and power a useful device of some kind. For those of you who don't know Jeremy, he's here, and he has one of those very low power okay. I won't talk about it tonight, but one day Jeremy will tell you all about it. So, The second thing, of course, is advancing technology in batteries, which are lower, which are, of course, advanced batteries, which are much smaller than they have been before. There's no Moore's law in battery technologies, but things are kind of grinding on, and every year we see things improving in the battery space. And, of course, there are new innovations in these fields, and our panelists are going to talk a little about some of them. We'll probably talk more about vibration and thermal than we will about the others. So, small amounts of power cannot power your home or power your car. But those small amounts of power could power a sensor in your car, in a place where it would be tough to install a battery or maintain a battery or change a battery or have wiring. We'll hear a bit about this. Small amounts of power can charge batteries in places which are inaccessible or expensive to replace. So this space says that if you put a device where there is sunshine, where there's something that's shaking, something that's vibrating, where there is RF energy, or there is a temperature gradient, there are 2 points with different temperatures, then we can power devices forever, or at least for a very long time. And that's what this whole conversation tonight is about. And to set the scene, I'm going to introduce Yad Garcha from Bionic Power. Yad has one of the many technologies that we're going to talk about this evening, and he's going to explain about what Bionic Power is doing right now. Yad.
That one.
Good evening. I'm with Bionic Power. What Bionic Power does is we harvest power from walking. And the outrageous claim that I'm going to make is that we do this, harvest this power without any or very little metabolic effort. I'm going to show you how we do that. We actually harvest about 12 to 13 watts of power on the level, on average. How do we do this? Before I get into Bionic Power itself, let me give you some perspective on some of the harvesting devices. This automatic watch is actually a harvester. It produces microwatts of power. So there's a small weight inside, and it moves back and forth, and it produces the power that keeps this watch going for 24 or 48 hours. Now, if you scale up the weight that's inside, you get this. Basically, it's the same concept, essentially. You're getting, on the backpack, you're getting about 38 kilograms, which is over 70 pounds of weight going back and up and down. It can produce substantial amounts of power, but it is quite a load to carry. So it isn't just the weight that we can carry. Some of us carry substantial amount of weight on our own. And so in the 1990s, it was postulated that there was 60 watts of power available in the heel. If that was true, our shoes would be on fire most of the time or all the time. In reality, most of that power is dissipated in the joints and tendons, and the best of the breed of these shoes produce less than half a watt of power, and it felt like you were walking in sand. And the joke among the military is, if you're walking in sand already, the last thing you want to do is to feel like you're walking in deeper sand. So our co-founder of the company, Dr. Max Downwin, started looking at the joint to see how much power is generated by the joint. So this is kind of a complex graph, but I'll explain what's going on here. He looked at several different joints, he and his colleagues, and what we have at the bottom is one gauge cycle. And on the left, we have how much power is being produced by each joint, expressed in watts. So you'll see that the ankle is producing substantial amounts of power, up to 200 watts. And same thing with the hip. So if anything that's above the zero, that's positive work being done by that joint. Positive work is really accelerating, doing some real work. And anything that's in the gray, that's doing negative work, or it's doing braking. So what you'll notice is knee is actually doing more braking than accelerating. Now, if you can come up with a device that captures, it it selectively engages when the negative work is being done. Then we can help the body do some of the braking and at the same time produce the power. That's what we do. This is why we're able to produce power without any or very little incremental metabolic cost. On top of that, we actually help the person walk downhill. Our chief engineers who is here, he recently did some studies. Going downhill, we actually save about 20% metabolic effort. And on the level, he measured that it costs about 2 to 3% of extra effort to produce 12, 13 watts of power. So we're not breaking any laws of thermodynamics or physics. This is a very elegant approach to what we're doing. So I'm going to show you what this device looks like. And some of you saw this earlier, and I don't want to take the chance of playing this inside a PowerPoint, so I'm going to show you like this. So this is our, ooh. Play again. Okay, I'm no Windows expert. We'll try to run this sometime during the presentation, all right? So, trust me, it produces power. But we will show it, and we do actually have the device here. So, that's a lot of power. So let me just tell you what this device was going to show you, that we're producing about 10 watts of power, 10 to 12 watts of power on the level. When you're going downhill, there is a lot more power available. We're capturing 12 to 25 watts of power, and it's smart enough that when it's going uphill, we go down to about 6 watts of power. So our target market is the soldiers. The last thing you want is for them to be producing power and feel bagged. They're carrying enough weights as is. The last thing we want is for them to be feeling like meals. The market that we're going after is the military. It isn't just the consumer who's using more and more devices, and the devices that we carry use more and more power. For the military, it's even, sorry, I need to go back into this mode. Why does the military need more technology deployed? Because the soldiers need to know where they are physically rather than having to pull out a map. They need to know where their buddies are. They need to know where the enemies are and what the battle plans are. They need to see at nighttime. They need to communicate with their peers as well as their command level. So all of this technology simply adds up. And I understand Rex said the battery technology is getting better, but the military is very conservative. Lithium-ion batteries are very novel for them. So when you deploy more technology on the soldier, they simply throw more batteries at them. This poor person is a special ops person. Special ops people can be away from their base for a month at a time, and who knows how many batteries he's actually carrying. But the Canadian military has estimated that a 72-hour mission can require 13 kilograms of batteries, or about 28 pounds. Most of that power is actually thrown away. So it isn't just the weight, it's cost. DARPA has estimated that it costs about $1.86 per watt hour in the field. And if you calculate that out, it works out to over $160,000 per soldier per year, just in batteries. And 95% of that is logistics, getting the battery out to them. So that's not the only market that we're going after. The second market that we will tackle is the first responders. When disaster hits, there is no power, whether it's in Japan or Haiti or Katrina or 9/11. The first responders are out of their cars. There is no power from the grid. Their two-way radios run out of power sooner than they normally do. Homeland Security has a stockpile of batteries that they have sitting around waiting to be deployed. Our technology can replace some of those devices, some of those batteries. 2.6 billion people are either without power or without reliable power. There are a number of technologies that can be deployed for them. We are not pursuing this market at this stage because they simply don't have the money to buy the technology at this stage. We would have to get the product down to $50 to $60 per device before it can get there. But some of the applications are people having to purify their water, people having to few people have devices, but if a medical worker is to diagnose someone with AIDS, they have to go back and tell them that they have AIDS a month later. They can't find them. So point of care diagnostics, and then being able to keep their vaccines or the medications cold, and then the communication. Those are some of the applications that we're looking at, and we will not be doing this alone. It'll be through partnerships. There certainly is an application. This is an enabling technology for orthoses as well as prosthetics. Prosthetics are basically replacing limbs. Orthoses are basically giving back functionality to the limbs that have been lost due to disease. Very few prosthetics exist because the power simply isn't there. Lastly, there is a consumer market for it. This is not for you and I. This is a lot of power to put this in context. We can probably charge 4 cell phones by walking for 1 hour. This is not for everyday use as you walk around. But if you are in the backcountry and need technology, then this certainly is a possibility. In terms of market, there's 62 million soldiers who could use this, but it's not likely that all the 62 million soldiers are going to need this. A lot of those soldiers are in China and India. They don't have a lot of technology deployed on the soldier. Initially, we'll be going in as a backup power for a section. Each section has at least one long-range radio, and the radios do run out of power. Two-way radios, there are 2 million two-way radios sold every year. Not every one of them is going to need this power, but certainly a big percentage of them could use it. This is simply insurance. And I talked about the third world market and the medical technology. In terms of the market status, we are primarily at this time, going after the military market. The Canadian military has funded this technology. The US military is now waking up to this technology. This is a disruptive technology. They didn't anticipate this coming at them, producing this much power this quickly. So they're getting around to assessing it, testing it, and we think they'll fund it. We will have mil-spec product within 18 months. And after that, we will do more extensive field trials. And all the other markets, we will only go in with partners once we commercialize the product in the military. Funding, we live on fumes, and I'm getting dizzy. So 1.5 million from friends and family, Canadian military, and tax refunds. So we have essentially bootstrapped this company. But we've got it where people are now interested in figuring out how to have exclusive rights to it or do something with it. Going forward, tax credits in Canada, we get 35% of expenditures. And we think the US military and the Canadian military will fund some of the trials that they want to do. People are knocking on our doors to look at strategic investments. And we're still looking for new investors because the best way to do deals with the strategic is if we don't need them. Lessons learned. This is a disruptive technology, and the disruptive technologies have positives and negatives. The positives are that there is an IP space available. People were not looking in this area. We have a very broad patent coverage, issued patents. But at the same time, there are people who are skeptics, and there are some people's jobs depend on working on the technologies that they've been working on for 10 years. So you really have to work a little bit harder to convince them this is real. Our largest customer is the US military. We may as well be in Timbuktu being in Vancouver. We have to travel all the time to Washington. If I was to do this over again, it would be in Arlington area. The long selling cycles, everyone kept telling me they don't want to invest in this company because they're long selling cycles. We've proven them right. And I think the only way to deal with that is just accept it and organize a company accordingly. Look, the only way to win the race is to finish the race. If you run out of money before the race is over, there's no point. So that's why we live on fumes. At first, we thought the large vendors, the prime contractors like the Raytheons, Boeings, and so on, would help us to develop the product and get us to the end customers. That's simply not the reality. They are not technology driven. They really respond to the requirements of the customer, and they throw a lot of bodies at it. And they eventually will come around, but in early stages, they're not there to help us. Our exits, very, very likely, will be one of the defense contractors or a power specialist. Power specialist is somebody who supplies power to the military. And we will try somewhere along the way, if we can get the video going, we'll show you the video. Thank you very much.
Why not? Very good. Thank you so much, Yad. So we have a number of questions to ask this evening. We need to ask whether energy harvesting is a relevant technology. We have to find out which are the best technologies for certain applications. We need to find out whether energy harvesting is just convenient or also is it also economically viable. We need to find out whether we've passed through the disruptive barriers we need to have passed through to make this today's technology, or whether the disruption's still to come so we can make it, so we'll need to make it tomorrow's. We need to find out more about the pitfalls. Thank you, Yad, for telling us some of those. And most importantly, I think for many of you this evening, what's in it for you? Is there money to be made in this space? Is this an area you should be getting involved in? So to answer those questions and many more like them, including your questions, and to that point, could you please remember, fill in your yellow cards, pass them to the ends, and then pass them down to the front, down to Hiroshi, please. Get your questions ready. To answer those questions and many more like them from you, we're going to invite our very distinguished panel up to join us. Please join me in welcoming. And as they take their seats, I'm actually going to ask each of them, if they will, to introduce themselves. Yad, do you introduce yourself again, or are you done with introducing yourself? Robert, over to you.
Actually, if you could...
Oh, yeah, let me find your slide. Well, in which case, Cyril, introduce yourself while I find Robert.
So, hi, I'm Cyril Ventura with Robert Bosch LLC in the venture arm of a large German corporation, and we invest in four technology fields: controls and automation, so sensors, electronics, power electronics, etc. Clean tech, anything there but biofuels, so local storage, local generation, etc. Then we have enabling technologies, more software-related topics, human-machine interface, wireless sensor networks, power harvesting is also one of the technologies there. And then lastly, healthcare, and that is mainly around remote patient monitoring and point-of-care devices.
Robert, you might as well take over now.
Yeah, what you're seeing behind me is a MEMS-based energy harvester. There's 4 cantilevers. Each cantilever is a single chip, which is 1 square centimeter. Each one of those is producing 200 microwatts at 75 hertz and 1 G of acceleration. This is something that has not been done before. This is you're hearing it for the first time. We have not made a press release, but we just actually confirmed it this week, so we felt comfortable actually telling you, and we really don't want to have any more cold fusion type problems out there. But again, my name is Robert Indoska. If you can just go to the next slide. You can see here, we actually just this week we've hooked this up to our Bolt energy harvesters, hooked up to a Symbet Enerchip board with two of their advanced thin film batteries, a TI radio, and so forth. And then the last slide is just showing who I am. So Microgen Systems is located at the Cornell Business and Technology Park, and we're doing work at the Cornell Nanoscale facility, doing all the development, and this summer we'll be releasing our first alpha level products to the wireless sensor network community.
Very good. Ahmad, you're up.
So we do chips. We do custom electronics. Our focus is power management. I like this quote. I was with my 4-year-old in Tech Museum, and it pretty much says, don't listen to the older and wiser people. So don't listen to us. But we are not older. We're probably a little bit wiser. I don't know. We do what you go to the big box company, and it says it's not possible. So we do the power management, and I'm taking an issue with Rex. He talks about low power microcontroller, battery, energy source. What the heck happened to the power management? That's a big piece that's missing, and it's been missing for a good while. So that's what we do. And we are in San Jose, self-funded, 100% employee-owned. That's it.
Terrific. Thank you, Ahmad. Nick?
Good evening. I'm very happy to be back at Stanford. Graduated from here 30 years ago, and so while I might not be wiser, I'm certainly older than 99% of the people in this room. Perpetua Power Source Technologies is in the business of commercializing thermal electric technology, and the word technology has been used an awful lot tonight, and I think that is one of the Achilles heels of this business. This is not a technology business, this is a solution business. And what Perpetua does is build solutions. They are renewable batteries. They happen to harvest the differential in temperature between the hot side and the cold side, but they look, feel, and act to electrical circuit just like a battery. It replaces a battery.
Outstanding. Well, thank you, panel, very much. We're delighted to have you here this evening. I'm going to ask Cyril if he will kind of lead us off this evening, because I want to kind of set the scene with an expert in the field. Cyril spent quite a bit of time at the Bosch Research Labs, locally, I think. Am I right?
Yes, in Palo Alto.
Yes. So perhaps you would just talk us through, Cyril, a bit about energy harvesting and how each of the four main energy harvesting technologies work and why they work and which applications they're best suited to and what the market looks like, and maybe the rest of the evening could be covered by that. Thank you.
I'll try to give a quick overview here. So you already introduced the technologies. So we have kinetic vibration or vibration harvesting, which can be either piezoelectric, capacitive, or electromagnetic. Then we have thermal, so like Perpetuum is doing, where you need a temperature gradient, and then you need to use the thermoelectric effect, and the amount of power depends on the temperature gradient that you can maintain. RF harvesting, so that could be either from a dedicated source where I have a dedicated RF source, which then sends out a signal and is received by a receiver locally, or you just harvest from all the RF power that is around, from cell phones, TV signals, etc. And then you have small photovoltaics, where we talk about a square centimeter size cell or so, which would then either from ambient light or from the sun. The amounts of power that we're talking about here, just to make that clear, we are talking about microwatt, hundreds of microwatts, maybe in the order of milliwatts. Okay, here in your case, we're talking about watts, but this is from humans. So mostly, if you're talking about wireless sensor networks, it's hundreds of microwatts. And it's clear that we're not talking technology one size fits all. So every technology has to be specific to the application, because the source is specific. So for example, if I talk about vibration harvesting, I need to know about the spectrum. Do I have a noise spectrum? Do I have any peak frequencies? Do they change over time? So I need to know the system that I put this solution in. So we also talked already a little bit about it. It's a system solution, and there are different components, and I would even say you should start with the application and then work your way down into what the power harvester should be and how this whole system should look like. Concerning quickly about the market, right now it's an emerging market, and there are a few companies which have found their niche in this market. For example, in Ocean, there was tonight at the reception, there was NXP showing a light switch which had an Ocean switch there, and so they're going for building management, and where you could put any switch on any wall. I would consider this as a niche market, but they've carved a very nice niche for them, and so there are a couple of such companies, especially in the mesoscale, where we talk about a harvester of the size of an apple or a fist. The small-scale harvesting is very much emerging, and honestly, I'm still looking for a company that comes up with a good solution where you come from the application, and would be happy to learn about more tonight. Where I see it in the future, wireless sensor networks, changing a battery, there you have a compelling point, because it's the cost of changing a battery, and batteries usually last 3 years, more or less, so some a little less. So after a couple of years, you will be changing batteries every day if you have many nodes out there, and some of those nodes you won't be able to find anymore. And then portable power, augmenting the life of a battery. I mean, that would be really, really a dream if I wouldn't have to charge my cell phone anymore. But so far, I don't want to run. Sorry, but I don't want to run around with a bracelet, but or brace around my knee. But that is certainly something where an application, maybe a car key fob or so, could be powered by that. And because there, the cost of changing the battery is just the labor involved is actually quite high.
Thank you. You covered a lot of ground there. Ahmad, I want to talk to you, I think, for a second. You come at it from a kind of different angle, I think, from some of the rest of the panel. You've got a long history in this space. How big is this market right now? And tell us a little bit about some of the things you've seen over the years. I think you've been in the space for about 20 years. What have you seen?
Well, I've been looking at it for 20 years. I started looking at it when I was in college. And because my wife is a nurse in VA, and one of the complaints they have right now is the soldiers coming back with back problem. They carry so much weight. Out of 140 pounds of weight, 40, 50 pounds is battery. So they are out of commission because they got back problem. None of them are shot. So now I have a little bit of I was telling Yap, I'm a little bit of skeptic, but not enough 4 pounds on top of that. So if it helps, it's great. If not, there's shoes he showed, I saw it in 92, and I was following this whole market, and I have a personal interest in it. My wife wanted a system that powers up the pacemakers 20 years ago. And the discussion was, can we power up the pacemaker so the patient doesn't have to go to outpatient every 2 years or 4 years and change this whole thing? What I see, generally speaking, is in the business right now, still is the same way as 20 years ago. It's like going to Home Depot. You find 2x2, 4x4, nail, cement, and glass and door. You don't get a blueprint for the house. And if there's somebody give you a blueprint, you still don't know how to put it together. And then there are experts out there who go to other experts who are in a big company, and they say, oh, you can't do this. So now we got electronics in there that got to glue all of these together. I mean, you got the energy harvester, you got the battery, and you got the system. Well, all of these got to work together somehow, which means electronics. On the microcontroller, I'm going to take a point with you. I don't think the microcontrollers today for energy harvesting are that good. They are either very high power and low leakage at low. So when you turn them off, the leakage is great, but they run them at 2 volt, 1.8 volt. So they suck. Now, if you want to go 90 nanometer, which is great, but now you turn it off, 30% of power, like Intel Pentium, which everybody knows, 30% of the power is leakage. So you turn it off at 90 nanometer, that's not going to work. So right now, the microcontroller itself, which is going to be the heart of the system, more or less, they're not going to work. People spend $10 on the battery or $100 on the battery, and then they spend 5 cents on the LDO. And they put the LDO in it, here goes 75% of the energy. And they go like, why this doesn't work? I'm like, well, think about this whole thing. You don't get your Prius and put diesel in it. I mean, I just don't get it. So what I see is, no offense to anyone, a bunch of chemists and physicists running it. And then go to the experts, and the experts say, can't be done. It just doesn't work. I can give another 1,000 reasons why it doesn't work. A true engineer finds the only way that it's going to work. The scientist is a skeptic. They're going to come up with 10,000 reasons why this damn thing ain't going to work. But the engineers are different. That's my opinion.
Thank you, Ahmad. Well, that's...
Hey, I mean, according to the NASA scientists, the Borton guy couldn't go to the space. I mean, it wouldn't have happened.
Well, I'm going to circle back to you for the other half of the story in a bit. Nick, what are the challenges in this space? Why is this not a bigger market already?
Well, how many of you know what an LDO is?
So I'm surprised.
Yeah, I'm telling you, they're using it.
But that's one of the reasons why the market isn't bigger, because the delivery of value to the customer is left as an exercise to the reader.
Yeah.
And you do need to know what an LDO is or power management is and so forth. 2 years ago, I started attending the events that the industry puts on for power harvesting. And what's the difference between an industry and a market? Industries are collections of sellers, and markets are collections of buyers. Industry events are exactly that. They're the industry speaking to the industry.
Yeah.
And so you drink your own Kool-Aid at these things, and you convince yourself that there's actually a market for this when there's not a single customer in the entire exposition. Now, finally, we're seeing signs of either emergence or early market maturation within this space. Because now when you go to the industry conferences, about half of the attendees are actually prospective customers. The amount of wireless sensors now that have been deployed are sufficient to run into the challenges faced with batteries. They don't last the life of the sensor. A sensor is anticipated to last 10 to 15 years, and Cyril was indicating that maybe the batteries last 3. Well, I don't know how many of you have deployed wireless sensor networks, but we get about 3 months. And the engineer is left with this Hobson's choice. I can either gather data once a day and allow my battery to last 3 years, or I can gather data on the pace that I actually need it, about once every 5 seconds, and get 2 months of battery life. And that's where energy harvesting finally is finding a niche. And that's where it's beginning to have commercial value to the customer, because we can finally power all of these sensors that are being deployed. It's the Internet of Things. Everything in this world is going to be monitored for condition and position, and that requires power.
Good, all right. Well, it's heartwarming stuff so far, but I mean, we're getting there. We're getting there. Let's talk about some disruption. So, Robert, I'm going to come to you, and you're developing a MEMS-based device which has some different characteristics from pretty much anything else that's out there. We've talked a little bit about it today, and it's an exciting moment. Talk about some of the things that you're doing and why you're doing them, and why the rest of the world is not going down that path.
Well, the biggest challenge for energy harvesting is you talked about the energy harvesters as the size of an apple. I say the size of my fist, in my big fist. These devices are hundreds of dollars. Micropelts thermal energy harvester is $637. I mean, how many people are going to be buying a $637 battery? So why do MEMS? Why do MEMS? MEMS it's really not about the size. It's really about the cost. It's about being able to do what the computer industry has done with computer chips. And you get more volume, you drive down the cost. And so the question is can you do it for the right cost? Can you produce the right amount of power? Can you make it reliable? And the next challenge is what now you have to worry about the operating conditions that energy harvester is in. And you put it on a bridge in Michigan, or Minnesota. You have to worry about temperature variation. So temperature variation is very, very important. Even in an industrial environment where you have a motor that you're monitoring that's at 60 hertz, your device may be affected by a resonant frequency device, as I showed up here, is affected by temperature. Your resonant frequency will change. And so how do you maintain that same frequency to couple with the equipment that you're monitoring? And so therefore temperature becomes a major hindrance to this. And Microgen has actually been able to, we have produced a significant amount of power, hundreds of microwatts, as you have indicated, which we anticipate, doubling that, quadrupling that over the next year or two, so that we can make smaller chips, so that we can make the chips, because the more chips you get on a wafer, the less the chips cost. And then you can then break into the market. So we anticipate at less than 1 million devices sold, our costs are going to be less than $10 per chip. At 50 million devices, it will be less than $1 per chip. So that now you start competing with a battery, replacing a battery altogether. But you'll always be teaming up with some sort of power storage device, and that's going to be the challenge in power management chips. Everything's going to be, it's a system. So explain to the audience what MEMS is. So, so MEMS is micro electromechanical systems. It's using the same techniques as building computer chips, except you're making little micro machines. So this projector up there has deformable mirrors in there that are MEMS that were built originally designed by TI. One of my team members probably holds a couple of those patents from TI, my packaging and test director. So that is a MEMS device. It's a little micro mirror that moves around with some electrostatic actuation, and it's a moving device. So it's unlike a computer chip where there's nothing moving. It's just electrons moving through through some sort of material, conductive material or non-conductive material, and so forth. So MEMS can use the same techniques as computer chips to build them. So the more you make, the cheaper they get. So that's the bottom line for using MEMS.
Terrific, thank you. Very good. So let's circle back to Yad. We're kind of going to move the conversation a little bit more into financing and markets and so forth now. And here's a question really specific about the market you're going after, Yad. I mean, the military market is a market which is seen as being very conservative and tough to penetrate. It's a market which most of us wouldn't consider going after as an early stage startup. Why have you chosen military?
So we looked at all the different markets. There was the military, first responders, medical, consumer. A lot of the markets that had large volume simply didn't have the money to buy the product. So I couldn't see myself making a $3 generator that can go into one laptop per child that sold for $100. It just, the investment that needed to go in was simply too much. For the first responder market, it was essentially an insurance market. You're giving them insurance just in case there is a disaster, and we will give them power. That's a harder sell. I'm no actuarial, but it's difficult for me to sort of quantify and tell them what this is worth to them. The military, on the other hand, they came knocking at our door saying, we have a problem. We're deploying more and more technology and more batteries, and we're spending a lot of money on them. There is no solution. They had this analogy, basically, they're saying they're using a soldier as a Christmas tree. They continue to hang different ornaments of technology on them, and they continue to throw different types of batteries and more batteries. There was no integrated approach, and they need to have a solution of charging batteries in the field, and they told us that they're willing to fund it. So when the customer is that eager to actually fund us, and we could actually design trials to show economic returns for the military. So it's very compelling. We hypothesize that if their numbers are valid, then we can show our return to the military by using a device that pays for itself within a few weeks to a month. And that's the reason why we went after it. The military acknowledges that it's difficult to fund startup companies focused on defense, and they're willing to do what they can to help us. The Canadian military has gone out of their way not only to give us money, but they have written documents that really sort of gives a roadmap to the industry what their priorities are with respect to technology gaps and technologies that they want to see developed. And they've identified our technology as number one that they want to see investment going to. How that will play out, we don't know. The reason why we picked it is because a customer came knocking at our door saying we want this.
And you can live with the long sales cycle.
Well, we simply have to acknowledge that it could very well be 3 to 5 years before we see real signs of revenue coming back, and we have to organize our company accordingly. I couldn't hire a BD person, have a $500,000 burn just from a BD, and when the check may not come in for 5 years. So it really has a huge impact on how you organize your company.
Okay, very good. Well, good response. Thank you. Robert, I'm going to actually move back to you. You talked about some of the characteristics of your technology, and you talked about scale and price and the TI guy, reliability, some of the things that you are, the effectively technical risks you are squeezing out of this process. Talk to us about de-risking the technology and fundraising and the steps that you've taken to get to the point you're at, and maybe tell us a bit about how you funded the organization thus far and how you plan to go forward.
I had a very large bank account, and no, actually not. I actually started this with very little money. I quit my job, went go back to start my PhD, not over again, but finish my PhD dissertation, which I had started in the 90s. And I was really honestly, I was thinking of how am I going to get this thing built that the university doesn't have a clean room. And so, I started, we filed a patent that was pretty novel. This patent is called our VLAB device. It's vibration-induced broadband excitation, and everybody got excited. So at the university, this is the University of Vermont. It's not, huge. It's not, it's not Stanford. It's not Cornell. But we're actually building our devices at Cornell in the Cornell nanoscale facility. So what you saw up there was built at Cornell. We're funded by Cornell at this point, and it was really, how am I going to pay for my dissertation? That was how I started my this company, and this happened. I love MEMS. I love this technology. I've been doing it for 22 years. I just absolutely, it's one of my strongest passions in life. Then I read this article in 2004 in EE Times about futuristic factories make mesh, and I was wondering how they were going to power all these devices all over a factory. I didn't think it was going to, they were going to be able to do this thing. Then there was a solicitation for GM Corporation looking for cordless sensors for automobile applications. And I just kind of fell in love with it. Then I was reading a book by Dan Brown, the person who wrote Da Vinci Code, called Deception Point. In chapter 5, I get to chapter 5, and he's talking about power scavenging, with this little micro dragonfly with a needle in it so it can go, kill the drug cartel. And I'm like, hey, I'm writing a proposal for this. This is really cool. So it all really came out of like nowhere, a snowball effect. And we got the first $150,000 from the University of Vermont. There's a Seed and Innovations Fund. From there, that was the only equity that we've given away in the company is 5% to the university. To exclusively license the technology that I helped invent, and fortunately that works out well at the beginning, and then now we have to pay it back. So, but they get 5% of the company. The rest of the money we've over the last since 2010 we've raised $1.6 million in one form or another bootstrapped amount of money. Working with certain companies in partnerships where I was working as a consultant, and I was able to put my devices on their wafers and do it as part of my consulting fee. So normal consultants made $150 an hour. I was making half that, plus I was getting free devices on my wafers. So so it's kind of a fruit of your labor, I guess. The $1.6 million, $150,000 roughly came from the University of Vermont. $700,000 came from an Army Research Lab earmark to the Infotonics Technology Center, and that's where we were piggybacking my designs on their wafers. And then $620,000 came from a NYSERDA grant, which NYSERDA stands for the New York State Energy Research Development Authority. And NYSERDA is probably one of the few good things in New York that really work. It's like a 0.04 or 0.4% small little tax on your electricity bill that no one even notices, and it funds this innovation that really could enable these startup companies. And so we received a grant from our contract from them. It holds us to staying in New York, so that's one of the downsides, because there's a lot more money out here on the West Coast and in Boston. But I'm originally from Boston, so there's a very strong pulling sound back there. from the VC market. But it's really been, the first few years, it's really been bootstrapping the money together. And that de-risks the investors in the long run. So, there's very little of the company was given up until starting this year. Now we're in a $1.6 million angel round, if you want to call it a Series A round. We're raising money. If anybody wants to chip in, feel free. My pockets are pretty dry right now as well. We're running on fumes.
Is it getting easier?
Does it get easier?
Is it getting easier for you? I mean, have you hit the stage where the risk you've taken out is sufficient that now it's relatively easy to raise a Series A?
Well, the real issue, and I actually mentioned this in the interview earlier, is that angel investors, there's VCs, such as yourself, angel investors have become mini VCs now.
Yeah.
10, 15 years ago, they threw money at something because they wanted to say at a cocktail party, hey, I'm working with this company, and so forth. But now they want a 10x return. It's like
Bastards.
If I had known that, I would never gotten into this. Okay. And I would assume that the VCs have gotten tougher too.
Yeah.
They all want market traction. So they want to see sales. This is at an angel level, which is crazy. So I say no. It has not gotten easier. We're finally getting to a point where we're actually going to start seeing revenue this year.
Okay, Cyril, have you got tougher? Let me ask that question a different way. So you began to talk about the kinds of technologies that you're excited by. You talked about key fobs, and you said also that don't come with a component, come with a solution to a particular problem. I mean, the traditional thing for a VC to say. What have you seen? One, is this space becoming easier to invest in? Two, are you seeing things that you would like to invest in?
So, easier to invest in? No, I don't think so. I honestly, I'm still looking for a interesting company to invest in. We have one investment in the space, which is actually on the thermoelectric area, but they have a different market. So it's a thin film thermoelectric. It comes with chip cooling. That's their main market, and the power harvesting is a secondary market they're now starting to explore. And now, with thermoelectric being a little more of a generic technology, so I just need a temperature difference, and it doesn't matter how I generate this temperature difference. That could be something interesting. But again, they are now a supplier to somebody who is, again, only putting together a node, which is then a part of a wireless sensor network, which has to be a solution for something. So that's why I say I would like to see somebody to come with me, hey, this is a real problem, and power harvesting is part of the solution. So it's not really easy to find that company. And to your point that you made before on the vibrations, so you said the price of the cost of the device is going to be somewhere in the $10 range if you have tens of millions. Now, here the problem with vibration is how many applications do I have where I have really one frequency that do not change from application to application. So do you know how you're going to address this? Because I guess it's a cantilever system, so it has one frequency where it works best.
Yeah. To answer that question, is our technology roadmap starts off with this exact device. It's a very specific frequency device, 50, 60, 100, 120 hertz for the industrial market. That's our first product. We're focusing on that product basically to say, this is how we want to make a big splash out there. We want to say, oh, we got all this power, do a press release, get a lot of attention. It's not just about making a product. You got to get people looking at you. And I wouldn't be up here today if I wasn't trying to get my name out there and get Microgen's name out there, and so forth. So I'm very honored to be here. Graduate. Just for my background, I feel extremely honored to be here. But the bottom line is you're absolutely right. I mean, if you in an industrial environment, you could have temperature shifts in the building, and your resonant frequency can shift off resonance of the. Or the resonant frequency will shift off the frequency of the machine that you're monitoring. There's plenty of vibration out there. The lights are vibrating at 120 hertz and 60 hertz and so forth like that. But if the temperature drops, all of a sudden my resonant frequency device isn't working. So we have a technology that is the next evolution of this. And this is a broadband excitation device, and we call it VIBE, vibration-induced broadband excitation. I forced that one. So unlike our bolt device, which is basically a bolt of lightning, you get one peak and it can shift around a little bit. If that's only, it's plus or minus 1 hertz. It's a very high Q device. Whereas if we can broaden this to plus or minus 5 hertz, or 10 hertz, we can handle the variations within a building. If we can broaden it to plus or minus 50 hertz or 100 hertz, we can handle variations on the Minnesota Bridge that collapsed. And that's where our technology is going. And this technology has been proven in the laboratory at the mesoscale. So far we've done up to plus or minus 17 hertz. And so that now if your temperature changes, your resonant frequency doesn't really matter. You're going to still be able to generate power over a wider frequency range, and that's the solution that we're going forward with.
Okay. Very good. Thank you very much. So, gentleman over there, you're still with us. Good. Ahmad, I said I'd circle back you for the other part of the equation. I know that you know that there's some big opportunities in this space. Talk to us about the kinds of problems that energy harvesting is going to solve and the kinds of things that you get excited about.
So the show in Boston in November, I think I was telling you and a few other people, I'm going to tell you what I heard in the show. If some of you been there, then you heard the same. It's a repeat. So there are about 3,000 or 4,000 oil wells in Gulf of Mexico. Nobody knows what the heck is going on in there. So you can have another fiasco BP down there, and nobody even knows what the status of all those oil wells are. You got the planes flying. The Boeing was talking about it, that they want to know the integrity of the plane and yada, yada, yada. Remember last week's Southwest problem? 800 plane grounded. So he was saying we don't make an iPhone 1 million a day. We make one plane a month, but we may get 1,000 of these sensors in each plane, and we want to do X, Y, Z. This is what he was saying. The oil industry has roughly 400 to 500,000 of oil pipe underneath the ocean. According to the U.S. regulation, they don't need to be monitored. So all those oil wells and all the rigs are connected together. Every time a hurricane comes in, they move around, they break off, and nobody knows where and how. They send a robot down there, but they're not regulated. It's in the ocean. They were talking about these instances that they would pay for a system that can monitor their stuff. Another one that the oil guy from Chevron, I think, he was saying, we got this reservoir in the middle of nowhere, and we're going to send a truck out there every day, or maybe every other day, to check it out. It'd be good to have something out there to tell us what's going on in there, either harvest energy from the heat or whatever. So the application, if you think about it, is there. The Zigbee been around for 10 years. The problem is the battery life that one of you guys were talking about. Yeah, it's supposed to last 5 years, but in my opinion, bad electronic design using off-the-shelf crap, putting it together, and you get something that lasts 3 months, and you give it to the customers, oh, it's going to last 5 years, and the guy come back 2 months later, what the hell is this, right? And then you say, oh, the industry has a problem. Yeah, the problem is you created it. The industry doesn't have a problem that, you did it. It's similar to the LED lighting, anyway. But when you think about it, nobody provides a solution. Nobody wants to do it. It's very difficult to sit down and solve a problem. The easiest way out, I work in big companies. The easiest way out in every big company is not to do anything. No risk, you're not going to get punished. So you don't do anything, you just let it die. And then comes to a startup and whatever, we come up with a solution, and the app goes, talks to all these big guys, and they're like, the problem with a 40-pound battery, if you look at the system, electronic system soldiers carry, they're still using regulators from 1980s. I kid you not. And you look at it and go like, what is this? Oh, it's proven reliable. I was in National Semiconductor. We were selling one chip at 99.9% margin. We were the only seller, and it was going in the missile that was $15 million. Everybody knows about it. But who cares, right? The missile goes, hits a cave, whatever. Nobody was there, by the way. Just think about it, seriously. So the problem is what we create. We throw something over the fence. I'm done. I did my piece. That's your problem now. And the other guy does his, and you got batteries that have huge resistance. You put it in them. I mean, we got customers who talk about 50 microwatt average power. We got another customer who talks about average power that he wants to run it is about 500 nanowatt. Now, the peak is 200 milliwatt. You guys work at the duty cycle. I think you guys know math here, right? Business school, never mind. I mean, 200 milliwatt, you get down to 500 nanowatt, you say the duty cycle, golly. And then the guy said, oh, I want the efficiency of the DC-DC or whatever it is, 100%. I said, dude, you got a problem. Your duty cycle number is more than 500 nanowatt. And it's like, really? I'm like, are you an engineer? What are you? And then, anyway, the problem, there is a huge business out there. Government of Japan, I think some of you probably know, mandated early 2000 that every citizen of Japan needs to be monitored wirelessly using 3G, 4G, Wi-Fi, whatever they have available within the country. So a lot of companies in Japan are running to come up with systems that monitor a patient, whoever the patient is. So the doctor is in Tokyo, the patient is in Hokkaido, and the patient calls up, hey, I'm feeling dizzy, and he goes on the computer, log in, oh, yeah, okay, your heart rate is low, whatever. There's a company who came out of Tokyo Institute of Technology. They came up with this sensor. Runs on 2032 battery. And you got to replace the battery every 3 days. Yeah, $400. And you go like, okay, I give it to my 85-year-old grandma. She doesn't even know where the battery goes. And now she's on her own, and now I got to go from Tokyo to Hokkaido, change the darn thing every night, forget it. And I'm paying $400 for it, and the battery every 3 days? You pitch them to say, we can do a tech for you. Yeah, tech. We looked at that. XYZ company has this tech power converter. It only works for this. So, yeah, that's a 1997 technology. So there's opportunity out there. I just quoted you what the guys in Boston were saying. I didn't say anything about my customer now, okay? But the guys in Boston were very, very detailed in the show. And there's another show coming up in Germany in June. And the same group runs it. The same industry people and few customers are showing up. What I heard in Boston was most of the customers are bitching. They're just absolutely complaining about the fact that the solutions are not there. And the guys who are in industry, oh, yeah, we got this X, we got this Y. And the guy says, well, how do I hook them together? They're not going to work. So that is the biggest problem that I see. Customers are there if there is a solution.
Just like add a point, I like to use this. I read this article about Thomas Edison and Henry Ford, and each of those made very disruptive technologies. But we had Henry Ford with the car, and we had Thomas Edison with the light bulb. But they didn't have to just invent those two things to make it work. They had to invent the infrastructure that made it work too. So Henry Ford had to invent the gas station. Okay, so if you didn't have a gas station, you drive down the road, all of a sudden your car runs out of gas. It's the same thing right now. We've invented another car, but we didn't invent the gas station to fill it up. And that's what Microgen is doing. That's what other energy harvesting companies are doing. Is we're providing the gas station for the advanced thin film batteries that Symbet and Infinite Power Solutions, who are downstairs, are producing. They have the Ferrari of batteries, but it needs to have something to fill that battery up. Otherwise, it runs out of gas.
Good. So we're hearing a very consistent story, which is we need the whole product. It's very important. If you're going to get funded, if you're going to build something which the market will want to buy, you need a whole product. Nick, we're going to move to questions. I have 5 yellow cards here. That's all that you've managed to come. Oh, hang on, 6 yellow cards here. That's all you managed to come up with on this energy harvesting subject. So if you have questions, please bring them in. You've handled one already, which is very good. All right. So, but this one specifically for you, Nick. Here's the question. I enjoyed hearing about the technology. What's the problem you're trying to solve? And where will you be in 2 to 3 years' time in terms of revenue? Easy one.
Easy one, yeah, because I'm just going to amplify what's recently been said about what problem are we trying to solve is the powering of sensors. And if we look at where sensors are being deployed earliest and in the strongest numbers, they're generally in the condition-based monitoring of industrial processes and equipment. And so you think about a semiconductor fab, turbo pumps, roughing pumps. These pumps are $75,000 to $100,000 a piece. They're finicky little beasts, and they can go off kilter. They're rotating at 25,000 RPM, sometimes higher. And you can imagine what happens if the axle happens to be out of round a little bit. It can be exciting. But more than the $75,000 or $100,000 that these pumps cost, these are the backbone of a $100 million fab. That pump is down, that $100 million fab is down. And so we've got customers today who are trying to figure out how, in fact, do they keep a $100 million fab going by want of making sure these roughing pumps don't fail in the process. And so the problem that we're solving is we're powering an accelerometer that takes a vibration signature of the pump, because a vibration signature is going to presage a catastrophic failure event. It will give the operator indications that there's something amiss with that pump. And so it's an industrial network that's completely powered by the waste heat off of these pumps. If you look at the number of pumps that are in industry worldwide today that are 50 horsepower and above, roughly, 16 million in the United States, another 16 million outside the United States, and less than 1% are currently monitored for condition. And that is the biggest industrial engineering and process control challenge that we have in the manufacturing sector. The lost time due to unanticipated downtime in manufacturing, $1.2 trillion in the United States alone. That's just under 20% of our GDP. And so the problem we're trying to solve is being more efficient in manufacturing by increasing the amount of uptime in manufacturing. So where are we right now? We're in early production on two products. One that uses the industrial waste heat from pumps and motors. Those are available today for shipment in small quantities. We're ramping the volumes as we speak. We also have a commercial product that harvests the differential in temperature between the hot water line and the cold water line on a faucet. Ever walked through the airport and waved your hands in front of the faucet and the faucet doesn't come on? Those faucets run on 4 C cells. 4 C cells, do you know where they are? They're somewhere underneath the sink, and it requires a licensed plumber to come in and change batteries. And at an airport, it's going to be a union licensed plumber. And so that's the other problem we're solving is there are early customers that are seeing the real pain associated with the convenience of having sensor-powered devices. And the pain is batteries. 2 years from now, we'll be delivering devices that use the human body as the source of power. And they'll power physiological sensors. They'll power location sensors. And so we've used in I think it was YAD, the Department of Homeland Security and First Responders. We send firefighters into a burning building with 0 sensors. The level of health sensors that we have on a firefighter, they come out of the burning building because their oxygen supply is just about gone. They're getting a new bottle of oxygen, and they say, "You doing all right?" Mm-hmm. "Yep, I'm doing all right." Yeah. And they go right back into the situation. No physiological monitoring at all. And so by using the temperature differential from the body to the ambient air, we'll power things like stress indicators, pulse oximeters, and location devices, so the unit and incident commander will be able to monitor the location of all personnel in an emergency situation and their health and for their safety.
Look at the Fukushima plant right now. They don't know what's going on in there. That's another application for this thing. If they had something in there that's powered up from something except wire, right? Because Japan is lacking 20% power now. Everybody's having an outage, scheduled outage. So if they had something on there to tell them what's going on in Fukushima, then they wouldn't have to send robots and have that 150 people get sacrificed in there either. So that's another good example that's going on today. Oh, I want to say something about YAP. I forgot. A couple friends 10 years ago, they were experimenting with power generation for soldiers. Kid you not. Helmets, butane power generator, so you put it in your helmet. And I'm like, you gotta be kidding me. Well, butanes are available anywhere in Afghanistan for lighters. I'm like, dude, you're gonna put this in a soldier's head? No. Kids you not. I saw this thing. I think they slept, they were drinking, and we were playing poker at 2 a.m., and they just said it, what they do, and I'm like, you gotta be kidding.
There's an opportunity for you, Cyril.
This
Like that
is
one?
much better.
Yeah, okay, good. Okay.
So, but Nick, quickly. So you have here a solution, but who comes up with the problem? Do you go to a customer, hey, this is what we can do, and where is the problem? Or do you have to do a reference design? Do you have to find the solutions there? I mean, for example, with the faucets, who comes up with that?
Yes and yes. And I loved Yad's line that was have your customers be local or be local to your customers. So you pick a few lighthouse customers that are representative and can be leveraged into a broader industry. So we're fortunate right down the street from us, we have a number of semiconductor fabs. And so we can work very, very closely with these companies who own the semiconductor fabs. And then you write case studies and you leverage your experience and you being to propagate the solution from there just simply by being able to use an example that was successful from which you can create a business case. In other cases, like the faucet application, it was a cold call that they called us and said, we have this problem. Our batteries only last a few months and it costs $75 every time we have to replace it for a sink. And we know that there's hot and cold water there. What can you do for us? And so it's a little bit of a combination of both. Some was architected in the case of industrial equipment. Others was dumb luck. But rather be lucky than smart.
Right. Absolutely. We're going to need to go to kind of a speed round now because I want to get through some of these cards, and we have not many minutes left in the cycle. There are some questions here which we need to cover. There are a few questions about cell phones. People are obviously very keen to see their cell phone powered because it's really tough to change that battery, right? Apparently, or charge that battery. So a question here, with CPU, GPU, power performance gains, and battery fuel cell innovation, will energy harvesting be relevant for smartphones or tablets running power-sucking apps like mobile augmented reality?
No. I mean, let me take that one for a second. You guys look
20
at the
seconds,
iPhone.
Ahmed,
Have you
20
opened it? Have you opened and looked at it? You get a car battery in there. And you don't buy the phone because the battery lasts. You buy it because the apps. And you're going to look cool in front of your buddy. Yeah. You want a phone that lasts? Get a phone. Done.
Yeah, always will be at the limit of the battery, whatever.
Okay, anyone on this one? So, question, any prediction from the panel on when the threshold or the inflection point will happen in this industry?
No, it's
Well, personally, I think the inflection point is when a power harvester is no more than twice the cost of a disposable battery. Because in one battery replacement cycle, you paid for an infinite life power source. And that's going to be within 3 to 5 years.
I'm going to disagree with that. Navy is replacing 20 battery in their sonar devices. You said $75 for 4 battery? You know how much they're paying for that 20 battery? Take a guess.
$250.
$495,000. So the union guy looks cheap. So now, I mean, this is public domain. I read it on the web, okay?
No, must be right.
It's on the web. You want the link? I send it to you. It's from the Navy Department. It's on the web on the Navy. So now, I don't know if it's 2x, but if you think about it, that I got to send somebody for $495,000 to change 21, a dime? No, I don't think so. I think it's going to be at the point that if the system doesn't work and I have a $20 billion fiasco in my hand, would I pay $100,000 for a solution? Would I pay $100 for the battery? Would I pay $200? I don't know. It's going to come down to what is the penalty if I don't do it. And I don't think it's 2x. I think it's much higher than that.
Okay. Next question. This is a specific question. What's the required power for a minimal sensor node?
Well, I'll take a shot. I mean, the sensors vary all over the place, but what we use as the minimum threshold generally to counsel our customers is almost everything runs on 3 volts. And so you want 3 volts matched, and generally 2 milliwatts is, by the time you duty cycle to a reasonable level of data gathering, it's 3 volts, 2 watts, 2 milliwatts. Any disagreement on that in the panel?
The guys we're working with,
Knew you were gonna disagree.
we're low 100 microwatt. 2 milliwatt is like way too high. They're talking about the box that we had out there that we were showing. The maximum power out of that the customer going to run average is 100 microwatt.
Right.
And the other box that we had, they're talking about the 500 nanowatt. So
There will certainly be
it all
applications
depends.
that are lower, but in terms
Yeah.
of mainstream applications, you look at a mainstream Zigbee radio, an
I
accelerometer,
agree. I agree.
3 volts,
100%.
2 milliwatts.
I agree.
Well, the Symbet board that was shown out at the display, according to people there at Symbet, 100 microwatts converted over to their battery will power a TI radio every 20 to 30 seconds. So if your duty cycle is shorter than that, you're going to need more power.
Yep.
But if your duty cycle, depends on what your duty cycle is. If it's 10 minutes, 1 hour, how often do you have to measure something? For a tire pressure monitoring system, it's every 5 seconds. Mm-hmm. I was just visiting yesterday a tire pressure monitoring system company who were very interested in our technology, and I said, well, why don't you just monitor the tire all the time? I mean, the sensor itself only requires, the ASIC only requires like 3 microwatts. You don't need 100 microwatts because that's when you're sending out the signal. And he goes, well, that's because that's what the customer wants. I mean, the customer is the government. The government says do it every 5 seconds.
Yeah.
That's what, and then once there's a problem, it has to be every 1 second. Okay, but in reality is that you could actually have an energy harvester in there that powers it all the time and only sends out a signal 2 times. 1 to say yes, the sensor's working, and 2 when there's a problem. Okay, but the problem is us human beings say we want it all the time. We want to have the information all the time, and so the duty cycles get shorter and shorter and shorter, and so the power requirements get harder and harder and harder to maintain, especially in the military. They want it every nanosecond.
Okay, gentlemen, we're down to the last question. This one has 3 question marks after it. The question is, what is an LDO?
That's a 3 cents part you buy untested, 70% yield. So 30% gonna fail. LDO is pretty much the old-fashioned linear regulators. Bob Weiler came up with the whole design in 1970s. It's a linear reg. If you don't know it, write it down. LM317, LM318. That's an old-fashioned linear regulator. LDO means low dropout output, right? So the scheme is changed, but it's a linear regulator. So you can look it up in any old write-up, linear regulator. LDO stands for low dropout output regulator. It's a linear reg, old-fashioned linear reg.
Thank you, Ahmed. Great job. Thank you, panel, very much. Thank you all. Thank you, VLAB.